Right. Thank you for that introduction, Martin. Yes, my name is Stefan Kruger. I met several of you, not all of you, but I'm going to talk a little bit about AI, the trendy thing right now, in conjunction with Dyalog. Does it work? Should it work? Do we want it to work? Etc. A little bit about me. I'm a new APLer, first decade at least. I've been about 3 years at Dyalog, and previously I had a long stint at IBM doing something entirely different. But as Martin alluded to, I come from a computer science-y background. I spent a very long time at university. And part of my role at Dyalog is to be a sort of provider of an outside perspective, like what does the world outside of APL look like? The points I'm going to try and cover today is primarily the first one here, like AI for developer productivity. Do the LLMs today, do they make sense for an APL developer? Does it help you improve your productivity? I'm going to talk a little bit about other applications, semantic search, retrieval augmented generation, and I'm going to talk a little bit about the client libraries for AI that Brian has developed. But primarily on like AI for developer productivity, like what's the value proposition? Well, if you look on LinkedIn or something like that, you get the promises of 10xing your productivity, remove all the drudge work, and then there's some mumbling, and then profit, right? This is actually one that I picked up this morning from LinkedIn. There's basically this person doing stuff in 1 hour that took me 5 hours. I will share this secret. Just, give me your bank details. But what is the reality then? Well, I think, under certain constraints, the AI probably does improve developer productivity, provided that you are sort of firmly in its wheelhouse. Yeah? And what does that mean? Well, you're working in JavaScript, C#, Python, and a few other languages of that sort of ilk. You notice there's no APL logo here. And also, like if you're working on small, constrained tasks that tend to be more successful, or sort of bookwork in air quotes there. And what does that mean? Well, perhaps you're targeting a well-defined, well-documented API, and you need to figure out which functions to call. This is a sort of sweet spot for AI. And maybe you're doing some mechanical refactoring of a code base. That means, maybe breaking up a function that has become too large, and you're breaking up into small things, sort of keeping the logic unchanged. And maybe you're just moving things actually physically, moving things around, like you want to say that these bunch of files, they need to go in another directory. Stuff that isn't difficult, but just tedious, right? But the key point here is that these tools, they improve velocity. They don't automatically make you more competent, right? And crucially to that is that it doesn't turn interns into senior developers. These tools are productivity tools for people who know what they're doing, right? Like if you are already experienced, this kind of thing can make you more productive, but it doesn't really improve your journey from an intern towards a senior developer, I think. And specifically then for APL, well, the situation is improving, and it's improving quite rapidly, but it's still not there. We're going to have to try a little bit harder, I think. And this is, part of the point that I will be covering on the next couple of slides. But let's take a moment to appreciate the fact that the pace of improvement here is completely off the charts. If you've been around for a few things, for a few years, you'll have seen other big things happening. But I can't really remember anything that's moved this quickly. Maybe not even the birth of the web. Right? But the world looks very different today from 18 months ago, or even like last week. And actually preparing a speech like this on this topic is actually quite difficult, because suddenly there's a new model that drops, and they have to go back and edit your slides because suddenly the stuff that you've been saying is no longer true. And I think today, Claude Opus, which is the sort of latest incantation from Anthropic, is perfectly capable of explaining even quite complex APL code. And it does actually mostly correct APL in constrained domains. Sort of correct syntactically, doesn't always get it right, but it's getting better. But I think it feels like, in terms as APLers, like we're about 18 to 24 months behind the curve, the sort of tip of the wave, the performance that you get out of Python. It's obviously a bit of guesswork, but it feels like if I think back 2 years ago, what has sort of got out of working with Python in this, it's kind of where it feels like kind of the same as we're now 2 years later with APL. But when Claude Opus 4 was released, which is the previous model, back in the summer, this comment cropped up on Hacker News. Some guy saying that he, for the first time he can produce sort of viable Dyalog APL code using an LLM, doing something non-trivial. I did actually contact this guy. He is a computational biologist working for a US Navy lab somewhere, and he's doing some analysis of DNA and RNA. And he showed me his code, and it's like hundreds of lines of code and dozens of functions. And according to him, it did take a little bit of prodding, but it wrote correct APL that eventually that ran without errors. And that was not something that you could have done earlier, I think. But when I was writing this talk, literally a couple of weeks ago, OpenAI dropped out a new model, GPT-5 Codex, specifically for coding applications. I've not had much of a chance to look at it, but from what I've seen, it's really good. Claude and Anthropic's Claude models have sort of been on the top of the pile for a while in terms of coding applications. But it's a busy space. I want to get back to this point that I made earlier, that these tools are perfectly capable of explaining APL code. I'm going to try and show an example of that. Yeah. So I know you can't read this, but I'll blow it up in a minute. But this is Advent of Code, which is a programming competition that runs every year. These I tend to use it as a sort of benchmark to test these models to see if they're improving their APL. There's small contained problems that have the nice feature that usually they have simple data and complex algorithms. So you get like a bunch of numbers in an array. You need to do some work on those and spit out an answer. Sort of, friendly APL sort of terrain. This one here is from 2015. This is the problem. Sort of summarizing a bit. It's basically find a Hamiltonian path in a graph. And we have 8 nodes in the competition problem data set. But basically, it's standard computer science fare, nothing complicated, and this problem is small enough to be able to brute force, right? This was my solution at the time. It doesn't really matter what it does. I make no claims that it's particularly clever, but it's got one or two things in here that probably would trip up a newbie and a newcomer to the language. I've used this PMAT function from the defense workspace to calculate permutations. I'm using this little idiom here to sort of map a set of strings to the index of the first occurrence. So I just fed this code into the Claude desktop app and say, explain what this does. And this is what it came up with. It's a little bit hard to see perhaps, but I think what it's done is explain the code in a perfectly adequate way. And I think if I'd written this, if someone asked me to explain my code and I come up with this, I would have been pleased with myself, right? And it's picked up on these two things, that the PMAT generates the permutations, and down here this idiom sort of indexing the positions to the unique IDs. So that it does a good job. But if you look at the tooling, the development of the AI tooling over the last, it's actually not that long. It's like 2 years or so, or something like that. Yeah, you might remember the original Copilot if you tried it. I remember trying it, and it just felt like magic. Like it felt like it was reading my mind. I started typing some code, and it just came up with this sort of autocomplete of 2 paragraphs of code, and I was like, how could it know that? Yeah, it's reading my mind. But the novelty of that sort of wore off pretty quick, and in the end, I find that I had to turn it off because and I think thinking back, it felt like when you sort of writing code, you're kind of in the zone. Yeah, you perhaps keeping the state of variables or something in your head, and then suddenly you get this bang, this autocomplete coming up, and even if it's mostly correct, mostly what you want, it's never exactly what you want, right? So what you have to do then is switch out of that zone and start sort of becoming code reviewer. And I found out after a while, it just broke my flow, and actually the net sort of productivity went down. Yeah, so in the end, I turned that off. The next thing that kind of happens, and it's still there, obviously, is this sort of desktop apps or the web page for ChatGPT and Claude. And some people, I talked today, say like, well, that's my line in the sand. Yeah, that's the most autonomy I'm prepared to accept from these tools. And then what you need to do, then you can upload your files into a sort of project drawer and these things, and you can sort of ask a question or query, and you get a response. And then it becomes a very deliberate act. Now you have to sort of look at it, and if you like what is produced, you can sort of lift it out and with care place it back into your own code. And some people, including me, sometimes like that way of working. And like it's putting sort of a limit on the magic. Yeah, you can see what's happening. And then we saw these AI integrated IDEs. Yeah, you may have heard of Cursor, Zed, Windsurf, etc. And almost invariably, Zed is an exception here, but they are either forks of Microsoft VS Code editor, or they're plugins to the same. So Windsurf obviously had its day in the sun when OpenAI offered to buy them for $4 billion for a plugin. That deal eventually fell through, but you can see the sort of money that's moving in this space. Now, I tried Cursor as well in the beginning when it came out, but it also felt a little bit like you could see the join between the two paradigms. Yeah, there's my editing paradigm, and then there's like a chat window, and that felt like an inefficient way of writing code, no matter how slick it was. And also it was kind of always one shot. Yeah, you asked for something, it will do exactly that, and then you have to ask for something else. Yeah, and I find eventually it also slowed me down. I mean, these tools, Copilot, and they're all sort of moved towards greater autonomy, and they look very different today from what they looked at the time. But the latest sort of version of these tools are console or cloud agents. Yeah. And what does that mean? Well, it was basically like your model runs in your terminal, in your CLI environment, sort of disconnected from things. And you may have heard of Claude Code, Ada, OpenAI, Codex. There's lots of these kind of cropping up, and these are very autonomous. Yeah, you set them off and they work for a long time, sort of unsupervised. Now this presents a bit of a challenge for Dyalog. What should we do? Well, one option, if we wanted to do this, like we can go for a sort of tight integration into the Dyalog integrated environment, the IDE. Now the problem that we have there, well, one of the problems is that our IDE is completely bespoke, completely sort of built, sort of in with the interpreter itself. It's not a clone or a fork of VS Code, so we can't sort of piggyback on the rapid pace of development that's happening in that space. And ultimately, these are very fast-moving goalposts. Yeah? These companies, they think nothing of releasing a point release that breaks backwards compatibility. Right? Anthropic recently changed their inference infrastructure, which basically changed the results that came out of this completely. Yeah? And they say, oops, sorry, we'll fix it. Yeah? That's not acceptable for Dyalog. It's not acceptable for you, for our customer. We have built up a trust capital, priding ourselves, on being backwards compatible, and stuff that you wrote yesterday will still work tomorrow, etc. Yeah? That's important for us. Yeah? I mean, these big AI companies are essentially, even though they're some of the most valuable companies on the planet, they're essentially overgrown startups, right? And we, as Dyalog, we are not in that camp. That's unacceptable to us, right? And ultimately, also these models, the performance is still below par for APL, which we've seen a bit. And no matter how slick that we could build something into the product, it still wouldn't be acceptable if the experience isn't great. Yeah, and we would then be beholden to these companies. Yeah, that's not going to work for us. So what do we do? Well, as it turns out, through amazing foresight, planning, and strategy, these console agents are a really good match for a link-driven workflow. Yeah. And why is that? Well, if you think about what link does, it kind of sits between the file system and the interpreter, and it kind of listens for changes. Yeah? So whenever something is edited on the file system, link tells the interpreter, hey, this has changed, please refix this. Yeah? And that means that we have a really fast feedback loop, probably better actually than you get out of something like Python or JavaScript. That way you sort of have to rerun your program after every change. And if we look at this sort of route, we'd need no UI overlays or chat panels built into the Dyalog environment, and we'd be less beholden to these companies. Like we can say, well, we have the mechanisms for you to experiment with whatever model that you like, and we will make that as easy as possible. So let's hone in a little bit on these console agents. So actually, the concept is pretty simple, right? Like it's an LLM that runs in a loop like this. And in that loop, the LLM has the ability to execute tools from the command line. It can read your code, it can search your file system, it can run your test framework, wherever it might be, it can talk to your source code management system, etc. And it runs your whole tool chain, like your test runner, your continuous integration, if you use that. And this is like high autonomy stuff. Yeah, you set it off, and you go for lunch, right? And then after lunch you come back, and there's a PR ready for your review. And a PR is sort of GitHub speak for, the suggested changes and the change set to your project. And you get this really visceral feedback, like on the cost that you're spending these tokens, as it's called, yeah, which is a sort of the units of text that the model deals with. Yeah, and this is actually can look like this. This is Codex. It was working on some stuff that I was writing, and then I hit my usage limit. So upgrade to Pro, pay more money, and then you can try again in 38 minutes. Yeah. So you get this feedback. Fortunately, many of these now support a more practical model. Like if you pay for the Pro, which I don't for this one, then you can essentially have all you can eat. And what are the implications then of using these console agents for Dyalog? Well, the most important thing is you need to store your code as text files, like Martin mentioned earlier. Nothing else is going to work, right? That these tools expect to be able to access everything as text. Yeah, and also you need the ability to run APL code from the command line. In fact, everything needs to be accessible and introspectable via the CLI. Tests, perhaps your issue system, like if you to pick up tasks and all those kind of things need to be accessible for this tool by running commands in your terminal. And rich error reporting is something that's important, right? Like if you think about something like Java has a very rich error reporting to the extent that it's actually get annoying for a human, right? Like you get those big dumps of stuff whenever something crashes, but actually that's very useful for the LLM to be able to sort of backtrace through this, quite happily reading those big stack traces. Yeah. In APL, if you get a message that says rank error, yeah, that's less useful if this is something that needs tracing backwards. So I'm going to try and show an example of trying to solve a problem in Dyalog using one of these agents. The actual run takes a lot longer, so I've compressed some steps for presentational reasons. But let's have a go. Yeah, and a reminder that the agent is just an AI that runs in a loop in a command line. Right? So earlier we saw Claude explaining my solution to this traveling salesman problem. This time I'm going to ask it to solve it. So I pasted in the problem description, and I said, what does this, solve this problem? This is what it came up with, like reams of code. And not only that, but it just doesn't work, right? So it doesn't do a very good job. I did actually complain about this, and it says, oh, I got a lot of the wrong end of lots of sticks. Yeah, basically it doesn't work, right? So can we do better? So I'm going to try everything I can to stack the deck in my favor or in its favor, to the extent that if some of you says that's cheating, that I'm okay with that. But basically, I've constructed a set of very carefully tuned instructions for this thing. I've given it the ability to run Dyalog code on the command line. I've given it the ability to look up idioms in Apple Cart, and if you're not familiar with that, it's Adam's very comprehensive idiom collection that you can search. I've given it a subset of the Dyalog documentation, particularly a list of all the system functions, because it's very fond of inventing new ones he thinks we should have. And I've given it a unit testing framework, which is modeled on Python's PyTest. So it's something they can run on the command line using essentially the same parameters as, could I do some water? Someone get me a glass of water. It's a small subset of it, but it also produces something called TAP, the Test Anything Protocol, which is a sort of standardized, machine-readable protocol for test results. Yeah? And this is something that the models already understand, so it becomes easy for it to. I'm using Visual Studio Code, which has sort of become the epicenter for open AI development. Microsoft's editor, it looks a bit like this. This is just a problem text to the left and the preview rendered to the right. I'm going to show you the run that I tried to do here. I've given it 2 unit tests. The first one just tests the example that was given in the problem description. The second runs the competition data set, and you can see I've given it the solution. Cheating, perhaps, yeah, but I wanted to just give it some something grounded, so to go through the process, really. I only used 2 prompts, and the first one says, read the task description, give me a plan, and let's review that. And then when the plan has been reviewed, I'm telling it to go and implement the plan, taking steps to test in the meantime. This is what it might look like. I know this is hard to read, I'm going to blow it up a bit. So here's my first prompt, read a task, outline the solution. This is actually the plan here for the solution, and let's review. I've given it some ground rules. Don't lie to me, write terse APL, use these tools that I've given you to execute APL and to look in Apple Cart. Don't invent system functions, please, etc. Yeah. And this is then the plan, and I'm going to highlight the option that it shows. It's actually a decent solution, decent plan. Yeah, it's figured out that it can use PMAT from defense. I did tell it about the defense workspace, that it had useful things in there, and it basically, honed in on the fact that whilst it's order n factorial, we only have 8 points in the data set, so it's viable for a brute force. Yeah. The next step then, it sets off and it cheerfully queries the Apple Cart things. How do I parse a string with regular expression extraction groups? Actually non-trivial, but it figured that out from Apple Cart. How do I split a string on spaces? How do I do a window reduction? Asking the right questions. But the next thing it does, that it actually figures out how to execute Dyalog code on the command line via this tool that I've written. And it returns the results in a machine-readable format in JSON, makes it easier. So it tests its assertions. And eventually, I should have highlighted this first bit here, but up here, it has run the solution correctly and got the right answer out as a Dyalog script. And then I asked it to produce a single defun. Oh, thanks. And this is actually quite interesting, I think. So it's tried to port its solution from a Dyalog script to a DYNA, but the rules are slightly different. So in a Dyalog script, it will just run from top to bottom. But in a DYNA, you have to, it returns from the first non-assigned result. Yeah? So here it missed that it needs to assign the result from this inline DYNA here. It did figure that out. Yeah? It ran the tests, and they broke, and it figured out the problem. And actually, the final solution it came out with is this. So it figured out how to do this extraction of groups from regex, etc. And it's a decent solution. It's maybe not completely fluent, but it works, and it's not terrible. If I compare it, so it figured out this, that it needed to assign the result of that inline DYNA there. But if you compare it with mine, it's it looks a little bit more Pythonic than the one that it wrote. But I think my conclusion is doing this kind of experiments is that an agent loop and tools used like this, produces better results than these sort of single shot, just type in and hope for the best, right? Unsurprisingly. And the thing that makes the biggest difference is giving it the ability to execute code, because it can then backtrack. Yeah? When it gets something wrong, instead of me having to point out that this broke, try again, it will figure that out itself, and it will sort of fairly quickly hone in on something that works. But ultimately, the productivity gain is a net negative. I actually spent a long time setting this up, probably about a day of tweaking and writing these little tools for, and my process was kind of like this. Like I started something, and then it got it wrong, and then we kind of worked a little bit together until it got it right, and then I said, so you got this wrong. What could I have done in the beginning, in the setup, in the rules, in the sort of guidelines for you to not get this wrong? And we agreed on some rule that we could put in, and I put that into the rules, and we tried again. Yeah? But now I have this set up, and of course it's slightly specific to this particular problem. But some of the rules are sort of crystallizing into something that may be useful in general. So the elephant in the room here then is that these models just aren't really good enough at APL. I mean, they are improving, but we're not there yet. And why is that? Well, I think the problem is obvious too, like that there is a lack of training data out there in APL for the models to learn from. And perhaps more importantly, there's also a lack of incentives for these giants, right? These giants are all, the OpenAI and Anthropic, they're all Python shops, right? They're training pipelines, and everything is written in Python. Everything in machine learning is written in Python, right? So for them, like even small improvements in Python pays great dividends for them because they use these tools themselves. That they have zero incentives for making these tools better at APL. And the effect that this sort of lack of training data has is that models don't learn good tokenization for APL code. You kind of imagine that a single glyph like rho or iota would get like a single token, but actually it's probably get many tokens because it's so rare in the data set, right? So I'm going to switch tack a little bit to talk briefly about semantic search and retrieval augmented generation. And these are AI applications kind of in the sweet spot of AI today. Yeah. This is the stuff that works well. And semantic search, or similarity search, or basically search for what I mean, not what I say. If you think about how Google search works, or just searching in a database, even with a full text search, ultimately it comes down to keywords, right? Like you might have something slightly fuzzy with a sort of regular expression or something, but ultimately you're matching patterns. Semantic search does something else. It tries to encode meaning, and these AI APIs that exist, they usually have models to create these vector embeddings. And a vector embedding is a long vector, thousands of points. And each sort of coordinate in that vector is a bit like a slider. It tells you how much this particular string that you fed it talks about some concept. It's talking about music? It's sort of 0.2. It's talking about jazz music, 0.5 or whatever. So you have and then you can sort of plot these vectors into like a massive multi-dimensional vector space, and each coordinate captures some kind of meaning. If you then do a query, you encode it in the same way. That brings you a point in this vector space, and you can find a radius around that in that high-dimensional space, and that captures documents, whatever you might have, data that is similar in meaning semantically. So a query then becomes a kind of nearest neighbor problem in a really large vector space. Like here's an image of a large vector space that's been clustered, but obviously then projected back to 2 dimensions. So you have to imagine this cloud being a cloud in space. Yeah. So if I have a query that sort of becomes a coordinate in this vector space, like my documents that are closest in meaning is some sort of sphere or space around that. I tried this, and I built a sort of vector index of Dyalog's new documentation, and I'm running that here as a web service, and I'm sending this question to it, like how do I serialize and compress a vector? Anyone know? Well, this is the result I get back if I blow it up a bit. It picks up on the right sort of 2 I-beams, which is the ones I had hoped for. And if I go back here, you can see like a normalized set of scores here, and they only make sense relatively. Right? Like it's hard to say. And here that the 2 top ones that I wanted was 52.8% and 49.0%. And what does that mean? It doesn't mean anything, but they're the 2 top ones, right? I've also built this into my ride here as a little user command. It's actually quite handy. I use it all the time, right? Like and then I get a sort of clickable link, and it opens the right page. Yeah. I have to be super specific about what I want. Yeah. It's actually quite a useful discovery tool. I think it was a gentleman at the front here that talked about notebook LLM. So if you want to experiment with this, Google has done a much better job than I could have done. But they have this thing called Notebook LM. It's free to use up to a certain number of queries, etc. But what I've done here to write here, I've basically added all our documentation as PDFs. Yeah, some of the older ones actually. And what it will do, when I query this, it will do one of these similarity searches. It will extract the right documents, and this is what's called retrieval augmented generation. It will inject that into my context and then answer my query within that context. So you can see here, I asked the same question: how do I serialize and compress a vector? It finds those documents and essentially gives me a summary and some examples. This is a really cool tool, and if you haven't seen it, take a look at it. This is using the Google Gemini model under the hood. I'm going a bit faster than I thought. So client libraries then. So the flip side of this, I have sort of mainly been focused on productivity stuff for the developer, like how can you use these models to improve your productivity as a Dyalog developer, someone who writes the APL code. The other side of AI is obviously how can you, as Dyalog developers of applications, build in AI functionality in your applications that you kind of sell on or for your users. This is where client libraries come in. This is the work that Brian has been doing. So these client libraries then allow you to talk to these APIs, these essentially web services that these AI companies provide. And that could be something like smart data of some sort, maybe forecasting or chatbots, assistants, whatever it might be. So we have a set of basic client libraries for open AI compatible providers, and this is a quite interesting development that since everything is happening so quickly, many of these providers out there, instead of developing their own APIs, they've chosen to implement a layer that is open AI compatible. It's a convenience for them because they didn't have to think about it, right? Like OpenAI done all the thinking, and you can implement the same thing. So if you have an OpenAI compatible sort of client library, you will also be able to talk to many other providers. So for example, most of the Chinese players, DeepSeek, Qwen, etc., they tend to be OpenAI compatible at the API level. So if you feel like you can trust these Chinese guys, they provide good value for certainly. They're good models, and they're also very cheap in comparison. This is where the OpenAI library for Dyalog lives.
It's still a work in progress.
It's a work in progress, and I get into that, and it's actually a harder problem than it seems, right? So these OpenAI and Anthropic actually API client libraries are auto-generated from an open API spec. It's a large YAML specification, and actually, if you look at the OpenAI one, it's actually the spec is 40,000 lines of YAML. Yeah, that's a big job, and actually, we don't have an OpenAI plugin for Dyalog yet. Something that we perhaps should look at, but what we need to do is pick out a subset of these APIs, yeah, and this is what Brian has done. Here's a little example. This is using the OpenAI image creation API. I asked it to create an image of a python eating an apple. That's what it produces, not Brian. And it's what it produces. You basically just say, it's very simple to use, like create this image. This is the size I want. This is the format. Run it and then display it in an HTTP renderer. Right? So it works pretty slick. So to wrap this up, then, the state of the APL AI nation. The situation is improving rapidly, but it's a fair way to go before we're really in a place where we can say that it's measurably improving developer productivity. But it does look like these agents, this console or cloud agents, will be the shape of sort of AI for development. Semantic search and retrieval augmented generation, these are applications that are solid, squarely in the sweet spot of AI today. So if you're looking to sort of build your own AI applications, these are probably quite common ones to look for. And you can use these client libraries that Brian's been developing to do that. So what will Dyalog do? What will we do as Dyalog? Well, this is the sort of thing we're trying to work out. But it seems clear that we have to improve our CLI story, testing, code evaluation, and things like that from the command line. And we've already brought out a sort of AI-friendly documentation format. The open source world, at least, seems to converge on using Markdown as the format for technical documentation. And what that means is that these AI companies, because they hoover up all the data, they have become very good at dealing with Markdown. Markdown is a high, it's got a good sort of signal to noise ratio compared to other things. I think also we'll be looking at improving error messaging, stack traces, and making those more easily available. They are available already, but make it a little bit easier to do. And we'll carry on working on these client libraries. We will provide examples and training materials over time. but also, as Morten was saying, like we will publish freely and available and open source all the APL code that we write, more or less. And this brings me to a plea, and perhaps the only way that this will sort of really improve if there is more APL out there, right? There's going to be several orders of magnitude more Python code out there than APL. We're going to publish everything that we do. That might not be possible for you, but perhaps you can help. You know, like, do you have like utility code that you've written? Perhaps you write APL in your spare time for sport, right? Like, is there anything that you can publish? If you don't know how to do that, you know, talk to us, and we will happily assist with that. So that was it. So I think we have a couple of minutes left for questions if anyone has to. Max.
So your advent of code example is insightful, but that's not really reflective of production code. Have you tried it on Kafka or Link?
Any other questions? No, but obviously that is. I have set it off on Link a couple of times, and I have this sort of idea that when I can say to the model, here's a GitHub issue describing a bug in Link, go and find it for me, and it will find it, then I can consider this job being done, right? But we're not there yet. Yeah. And with anything real, sort of anything or realistic, sort of more business-like, right? Like, it requires a lot of steering, and for me, it's not there yet, and it requires too much steering for it to be useful, right? So I think it will slow down at the moment any kind of real work rather than help you out.
So would you consider sharing the notebook LM that you created for your Dyalog docs that we could access? I mean, assemble those documents isn't easy.
Yes, it is shared. Actually, I think Rich put this together originally. I can make sure that in the communication afterwards, it's a little bit out of date now. I might make a new one with the latest versions of everything. Yeah. So.
And the second question is relative to sharing in the code. You know, as an owner of a whole bunch of code, some of which I'm not very proud of, and obviously it's probably, I hope it's improved over time, but inevitably you got this huge library of some bad code and some good code. How do you, is there any sense of trying to curate it so you have better code being provided as an example of these engines, and how do you protect the IP and perhaps even some shared secrets that you accidentally have sitting in your code?
Yeah, so those are very insightful questions. Right? So there's a couple of things there that you said, like does it matter the quality of the code? I think there's two aspects to that, right? If we just want to make sort of the general performance better over time, it doesn't matter so much because what it picks up on are like patterns, like snippets of code, and it learns from that. Yeah, it doesn't really look at a large piece of code and sort of figures out what it does. Yeah, that's not how the training works. Where that becomes important is in the sort of reinforcement learning afterwards. Yeah, so if you want something to become really good at APL, rather than just sort of generally improving, then what you need is perhaps 10,000 curated, very carefully constructed examples or something like that, and a human, usually, to sort of measure the response that comes back and say whether it's good or not. Yeah, this is usually how it goes. So there's two aspects that I think we're not there yet. Yeah, like we don't have that sort of code base, but any APL that's available will make the overall performance improve over time. And the other aspect was the IP and stuff. Obviously, that is a problem, right? But that is a problem with all code, like not just APL. So that's something that it's going to be individual to anyone who's considering making something public. Yeah, it's like, there's no silver bullet to solve that, I'm afraid. Yeah.
So when using it for prose, I'll write 1,000 words and say, get this better, faster. How is it at taking existing code and improving it? saying, here's the description of what it does.
Yeah.
Here's what I wrote. It does that.
Make it better, faster.
Just make it better.
Yeah. If you're using something like Python, it's exceptional. Yeah? I really can't stress enough.
How is it at APL doing that?
Yeah, with APL, not so much. Yeah? It understands APL, it can explain it, but it's not sort of creative enough to do a good job at making things better. Yeah? It generally stumbles.
So I would think that would be really useful, and then we could take old code base.
Yeah.
I have code from 15 years ago.
Yeah.
That would be an embarrassment, and get it the same thing running faster.
Yeah.
Tony, and then we need to.
Two questions, really. One, it wasn't clear to me whether all of this is working in just the RIDE ID or the Windows and the RIDE ID. And the second is, there's already a function in dfunds called minimum spanning tree.
Yeah.
And you pointed it at the dfunds workspace.
Yeah.
How would you prompt it to say, before you go crazy, see if there's already a function that does this?
Yeah. That's exactly what you would do. in fact, yeah.
Give it that instruction.
Yeah, you would say. I mean, but the thing is, like I tried to come. I mean, obviously, I'd solved this problem before. I knew that there are quite sophisticated graph algorithms in the dfunds workspace. Yeah. So what I could have done is I could have said, hey, this looks kind of graphy. Yeah. Why don't you go and have a look carefully? But I think it just honed in on it. It figured out. This is what I want to do. I want to sort of do a brute force thing. That means, calculating all the permutations. Is there anything that can calculate all the permutations? So it kind of honed in on that track, right? And it was probably the right thing to do in this case because it was a small data set, etc. But it's an interesting problem. On the other question is that this wasn't run in RIDE. It runs in VS Code. It basically runs in a terminal. It's a sort of independent from. Is that?
What is the question? Well, okay, there are two omissions in your APL AI integration. One is a RIDE, and you could, in theory, write an extension that operates with these AI plugins provided by in VS Code.
Yeah.
The other is that there is actually a VS Code extension in APL, but it's not owned by Dyalog. It should be, and it's written by Gilgamesh. So those two tools can integrate with the AI stuff.
Yeah, there's certainly scope there for investigating plugins and stuff.
Great. Yeah, great.
Thank you.